You have trained a machine learning model before, but have you ever wondered how to actually deploy it and make it accessible, scalable, and production ready? In this video, we will go end to end. Train a simple machine learning model, turn it into an API, containerize it, and finally deploy it on the top of Kubernetes. By the end, you will not only understand the steps, but also the concepts behind the machine learning deployment. So let's start from the scratch with model training. Before we jump into the code, let's clear a few key terms that often confuse beginners. When we say training, we mean teaching a model to recognize patterns from data. For example, in the Iris dataset, we feed flower measurements like petal length and width and teach the model to predict the flower type. The output of this process is a model file like model.pkl. This file stores what the model has learned. And next we have an inference. Inference is when we use that trained model to make predictions on the new data, like sending flowers measurement and getting back the predicted species. And deployment is the process of making that model accessible, usually via an API, so anyone or any system can send requests and get predictions. This is where the tools like Docker and Kubernetes comes in. They help us package, scale, and manage our machine learning services just like any modern microservice. So enough theory for today. Let's jump into the hands-on part and train our model. To keep things simple, we will use the classic Iris dataset from scikit-learn. It's a perfect beginner dataset for classification. So first of all, we need to install the dependencies which will be used in our code. So I have already created files for that. So these are the files which will be used in this particular demo. So first of all, we need to install the dependency which is stored in this requirements.txt file. So here we are using the FastAPI, UVCon, scikit-learn, joblib, and the numpy. So to install that, we will be using pip3 install -r and the file name, that is our requirements.txt. So pip3 is not installed, so let's install it very quickly. So yum install python 3 -pip -y. So it will install the pip3 for us. Now pip3 got installed. Let me clear the screen as well and the same command again. So this time it will install all the libraries which will be used in our demo. Now the dependencies got installed. Let's train the model. So for that we have a file called vi train_model.py. So this is the file which will be used to train our model. So at first we are importing the Iris dataset and a random forest model, and at last we are importing the joblib which will be used to save our trained model. Then we are loading our data like features and the labels, and after that we create a random forest model with the 10 trees and train it on the top of our dataset. At last, once the model got trained, we save it as a .pkl file. This file contains the knowledge our model has learned. So let's run the Python command to train the model. For that we can run python 3 train_model.py. And our trained model is ready and saved it as model.pkl. And if we do ls here, we can see this file got created which is having the trained model. Now comes the fun part. Solving predictions. We will build a simple API using the FastAPI that loads this model and exposes two endpoints, one for health check and one for prediction. So for that I have already created a file that is app.py. Alright, let's walk through this FastAPI code that's actually powering our machine learning model inference API. It's super small, but every line matters. So first we import the basics, that is FastAPI to build the API itself, base model from pydantic to validate incoming data, numpy for arrays, and joblib to load the trained model. Then we are creating our app here. Think of this as a spinning web server where our /predict endpoint will live. Next we load our model from the disk with the model equal to joblib.model and the file name where the model got saved. This is the exact same model we trained earlier and exported. When this API starts, the model is loaded into the memory once, so predictions are faster. Now comes the input validation part. We define a class called instance that extends the base model. It has one field called data, which is a list. This basically tells FastAPI whenever someone calls the /predict endpoint, the request body should look like data equal to list. Then we added a small /healthset endpoint. This is super important for Kubernetes. It just returns OK. so that kubelet will hit this route to check if our API is alive. If this goes down, Kubernetes knows it has to restart the container. And finally, the most important part, that is /predict endpoint. It accepts the instance object, extracts the data, turn into a NumPy array so that the model receives it in the format it expects, and then calls the model.predict. We convert the prediction to a normal Python list so the FastAPI can send it back as JSON. And that's it. With just few lines of code, we turn a safe machine learning model into a real API that Kubernetes can probe, autoscale and deploy anywhere. So to run this, let me run the command, that is uv-con app and the host information. So I'm running it locally. So 0.0.0 and the port I'm using 8000 here. Now our API endpoint is exposed and we can connect with our model using this endpoint. So let me duplicate this session. So to test this, we can run the curl command. So I'm running the curl command and I'm running it on the local host and port number 8000 and hitting the endpoint that is /predict with the content that is data, which is having the list of numbers. And if I hit enter, and we get our model prediction right from the API. If we come back to our previous console, we can see we hit that particular endpoint that is /predict and we got a response that is 200. Now our model works locally, but to run it anywhere like on Kubernetes, we need to containerize it. So for that, we need to create a Docker file for that, or the container file if we are using the Podman. So I've already created a Docker container file for that. So let me turn it off and show you the container file. So this is the container file. Here we are starting with a lightweight Python base image. And then I am setting up the working directory to /app. And here I'm also installing the dependencies, that is the Python dependencies, which will be used by our code. And the next step, I'm installing those dependencies using the pip command. After that, I'm copying the complete folder to the current /app directory and exposing the port 8000. And at last I am running the command, that is uv-con command, which I just ran locally. This is the same command I will be running on the top of container so that it will expose the port number 8000 and start the FastAPI with uv-con. Now to build an image, we need to run the Podman command. So let me come out of it and clear out the screen and run the Podman build -t and the image name. Here I am using k8s-ml and the dot notation. So Podman is not installed in this, so let me install it very quickly. So yum install podman -y. So it's installing the Podman, and once the Podman got installed, we will start building an image. Podman got installed successfully. Let's run the same command again. So now it's pulling an image, that is Python image, which will be used as a base image, and then it start installing the dependencies for the Python. Once the dependencies got installed, it will copy the files which is being used to train the model and run the API server. So it copied the files and exposed the port 8000 and ran the command uv-con to run our API server, and the image got saved if we see that. So Podman images is the command for that. If you're doing the same thing with the Docker, you just need to replace Podman with Docker, and here if we want to see the image, so we can run the Docker images. So this is the image we just created. So let's push it to the repository. So Podman login query.io. So first I need to log into the query repository so that I can push an image to our repository. So let me log in and enter the password here. I think I need to enter it again. So I'm able to log in this. So let me push an image very quickly. And Podman push. You will be curious why I am pushing an image to the query repository if I am having the image locally. So Kubernetes here is using the containerd as a container runtime for a Kubernetes cluster. But I build an image using Podman, and Podman is having that particular image stored in the system. So for that, first I need to load the image with the containerd using the manual way. Otherwise, I can push it to our public registry and Kubernetes will automatically pull that image from the registry using the container D. That's the reason I am pushing an image to the queue registry. So our image got pushed to the queue successfully. Now let's deploy this container to Kubernetes and make it accessible externally as well. So let me show you the manifest file for the same. So I've already created a ks-deployment.yml file. So here I need to update this image as well. So this is a manifest file for our API server. So here this is the same structure which I use in my deployment in Kubernetes video. If I go to the end of this file, I need to update this particular image, that is k8s-ml. It's k8s, and if you see, I'm exposing the port that is 8000 on the container. This is the same port which I exposed using the uvcon command. Here I'm only creating a one replica for this. That means one instance for now. I'm using the selector and labels here, so that label connects it to the service automatically. So I've already covered the selectors, labels, and the deployment in very much detail. If you want to understand that, I will add a link in the description so you can check it out. So let me come out of it and run this. That is kubectl apply -f k8s deployment.yml. So deployment got created. So I will run kubectl get deploy. So it created a pod, and if I see kubectl get pod, so it's creating a container. So let's run the watch against this. So it will pull that image, and now we can see the pod is in the running state. Now if we want to expose this particular pod, we need to use the service. So for that I have already created a file for that, that is service.yml. So here I am using the cluster IP because later on I will be using the Ingress to expose it externally. So this is the same structure which we use in our service video. So here I am exposing the port number 8000 for the container, and from the host we can access it via the port 80. So it's mapping our port 80 to our application port that is 8000. So let me come out of it and run the kubectl apply -f and the service.yml. The service got created. So kubectl get service. We can see this service got created with the cluster IP on port number 80. Now we can access our application within the cluster, but it's not accessible outside the cluster. So for that we need to expose it publicly using some ingress, or we need to change it to the node port or the load balancer. So first let's test it with the cluster IP itself. To test it with this particular service, we need to do the port forwarding. For that we can run kubectl port -forward service and the service name, that is ml-demo-service, and port number 8080 to port number 80. Because the service is using the port number 80 here, we have exposed our application on port number 8080. And if I do curl here with the same dataset, so let's run this command. And right now, earlier I used port number 8000. Now I'm using the port number 8080 because I use the kubectl port forward command to expose it on port number 8080. So let's run this. And here I got a prediction from the model, but right now it's running within the cluster, and I did the port forward. So I need to run this command at the backend each and every time. So once the command got failed or got ended or session got ended, we won't be able to run this command again. So as we can see, we are not able to access the application. So for that, I am going to use a resource called Ingress. So let me show you that. So I've already created an Ingress resource for this particular application, and here I'm specifying the RK2 server, which is our host name, and here I'm mapping it to the service, that is ml-demo-service, and also using the port number 80, which is being used by the service. So Ingress make it publicly reachable, and it routes external traffic from Nginx to our service inside the cluster. So let's quickly apply this. So kubectl apply -f ingress.yml. So ingress got created. If I see kubectl get ingress, so ingress got created. If I run the same command but with a different host name, so instead of localhost port 8080, I will be using the host name of this particular server. So rke2-server. So we got a response from our model. So our prediction API is live in the Kubernetes, and it's been exposed publicly using the Ingress resource. So we don't need to do anything apart from that. We just need to make an entry in the /etc/host file so that our system can recognize this particular host name. So let's quickly recap what we have done. So let me go inside this particular directory, and in this I have different files which we went through. So first of all, we trained a model in the Python and then build an API with the FastAPI and containerize it and deployed it on the top of Kubernetes. This is exactly how real world machine learning systems are deployed. Model training, inferencing AI, inference API, containerization and orchestration. In the next video, we will scale this application using horizontal pod scaler and add monitoring. So make sure to subscribe if you want to take this to the production level. If you found this helpful, hit like, share it with your friends and subscribe for more content like this. Thanks for watching. I will see you in the next one.